Okay, let's say I tell you that y is equal to 2x minus 5. Okay, that is the value of y. Now I'm interested in finding out what is happening to y when x goes to 3. Okay, so for that you can easily draw a table, pick values that are close to x, and then substitute them into your equation, and then see what is happening to y. From there you should be able to conclude, okay, when x is approaching 3, then y is approaching a certain value. So I'll draw such a table. I'll pick x values and then y values. So I'll start by approaching x from the right. That means I substitute values that are bigger than y, that are bigger than x into this equation. So if I substitute 4 into that equation, you'll have 2 times 4 minus 5. You see, you get 3. Then I say, okay, let me get even closer. But if I substitute 3.5, do that on your calculator, you get 2. Get even closer, 3.2, you get 1.4, 3.1, you get 1.2, 3.01, get 1.02, 3.001, 1.002, and then even closer 3.0001, and then here I get 1.0002. So here we can see that when x is approaching 3 from the right hand side, the plus there is just means that I am approaching x from the right, where numbers are bigger than 3. So I started with 4, 3.5, 3.2, 3.1. I substituted each of them into the equation, and then I see what I get. Now I look at my y values over here. If I look at them, first one was 3, then 2, 1.4, 1.2, 1.02, and so on. So I can see a pattern. These numbers over here are approaching 3. Okay, so I can see that y is approaching 1. Sorry. So it is approaching 1. Now it's good to also check from the left hand side what is happening when we are approaching 3 from the negative side. That means we start with numbers that are less than 3. So again, you can draw a table. You have your x values, you have your y values. Let's say I substitute 2, the value will be minus 1. I get 2.5, I get 0. I put 2.8, I get 0.6, 2.9, get 0.8, 2.99, I get 0.98, 2.9999, I get 0.9998. So even in this case, we can see that when x is going towards 3, but this time from the left hand side, so I have values that are less than 3, and I'm building up to 3, I can see that my y values here, minus 1, 0, 0.6, 0.8, 0.98, and so on, they are getting closer and closer to y. They're getting closer and closer to 1. So I say y is going towards 1. So the limit, so then from there we say that the limit as x approaches 3 of 2x minus 5 is equal to 1. Okay, so we say that is the limit. That's what we call it mathematically, the number that the function is getting closer and closer to. So we read it, the limit as x approaches 3 or as x tends to 3 of 2x minus 5 is equal to 1. So we can see that by observing our table over there. Okay, now I'm sure you can guess that if I just substituted 3 into this expression over there, if I say 2 times 3 minus 5, this is 6 minus 5, you can see that I will get 1, and that is the limit. So it's a limit I got using the table, and just by substituting it I could get the limit as well. Okay, so one way to find the limit of a function is to just substitute, because you're interested in what is happening to the y values when the x values are approaching a certain value. Okay, so that's what we're interested in. So we know what x value we're going towards. We want to find out what is happening to the y values. So we said one way, you draw the table and then you observe the pattern. You can see, oh, okay, when I'm approaching from the left, my values are going to 1. When I'm approaching from the right, my values are going to 1. Therefore, the limit is that specific value. Now, sometimes you can also work it out by directly substituting your limit point. So I put the 3 in there, and then I got 1, which is indeed the limit. But then other times you get something like this: y is equal to x squared plus 21x plus 20 over x plus 1. And we want to find out what is the limit of this function. So what is the limit of this function as x goes to minus 1 of this? So we want to work out what this limit is. Now we saw with this one over here, this one here, we were able to substitute directly, and the answer we got out was indeed our limit. But you'll notice that if we do that, if we substitute x is equal to minus 1, our denominator here, if I put x is equal to minus 1, my denominator will be 0. And we know that we are not allowed to divide by 0. But you will also notice that if I put 0, if I substitute minus 1 into the numerator, so I substitute there minus 1, I put minus 1 over there, my numerator is actually also equal to 0. So what I have is that this is of the form 0 over 0. So I'm looking for a limit, but when I substitute the limit point into the numerator, I get 0. And when I do the same thing in the denominator, I get 0. So I have something 0 divided by 0. Okay, now there are shorter ways of working out limits where you have 0 over 0. One way to do such, to work out such questions is by factorizing. Okay, so what we can do is we can factorize. So we have the limit as x goes to minus 1 of x squared plus 21x plus 20 over x plus 1. So we can factorize the numerator. So we look for two numbers that when we multiply them, the answer is 20, and when we add them, the answer is positive 21. So that's 20 and 1 plus 1. Then you can see that my denominator will cancel. and then I will be left with limit as x goes to -1. This is x plus 20. Then now what you can try and do is substitute. So you will substitute -1 over there. So you'll put -1. And if you substitute -1 now, you see that you have -1 plus 20, and this is equal to 19. Okay, it seems a bit strange, but we can always check if this is correct or not by substituting values in. So we start with our table again. So I have x. Now I want to work out what is happening to my y values when x is approaching -1. So I can substitute in -0.99. You'll see that I get 19.01. So you substitute this -0.99 over here. This is where you substitute it in. And then if I get even closer, from the right hand side, 0.9999, you see I get 19.0001. And then if I wanted to try one from the left hand side, that means I'm going towards -1, but I'm using numbers smaller than -1. So I have -1.01. You see that I get 18.99. And then if I get even closer, 0001, I get 18.9999. So even here you can see that there is a pattern that when I'm approaching x, which is equal to -1, from the left hand side or from the right hand side, these values are approaching 19. Same thing over there, these values are approaching 19. And when we did the calculations without using a table, we can see that our limit is indeed 19. Okay, so one way to find the limit is by using a table. Another way to do it might be by simplifying the expression that we have and then substituting. And another way is just substituting from the beginning if we don't have any problems in our substitution. Now another one is we want to work out what the limit is when instead of going to a particular number, we go towards infinity. So if I have something like this, what is the limit as x goes to infinity of 1 over x? What this means is I am dividing 1 by numbers that are getting bigger and bigger. So I could start with 1 over 1,000, 1 over 10 million, 1 over 100 million, 1 over a billion, and so on. So I want to find out what is happening to y. Here my y will be equal to 1 over x. So my x values are getting bigger and bigger, and I want to find out what is happening to the values of y. So I'm sure even when you think about it, you can say, yeah, the values of y should be getting smaller and smaller. So think about it like money. You have a fixed amount of money and you want to share that. The more of you there are to share it amongst, the less that everybody will get. Eventually everybody will get nothing. Okay, the number of people just keep increasing. So the limit as x goes to infinity of 1 over x, this is just equal to 0. Okay, and this is not just true for 1, it could be any fixed amount. So we have limit as x goes to infinity, let's say 2 over x, this is also equal to 0. Limit as x goes to infinity, even of a million, this is still equal to 0. Okay, because that 1 million is fixed. Eventually when x is getting bigger and bigger, it'll pass the 1 million and the denominator will be so much bigger than the numerator that what you're left with is very close to 0. Okay, so your numerator, if it is a constant, then the limit goes to 0. So the same thing is true if you have limit as x goes to infinity of 1 over x squared. So now imagine you're substituting bigger numbers that are getting bigger over here, and then you square them on top of that. Okay, so you substitute 1,000, then you square it. You can also tell that the numbers in the denominator are getting bigger. So you're dividing 1 by an even bigger number than when you were dividing it by x. So the limit of this is also equal to 0. Also, limit x goes to infinity of this one, x squared plus x. This is actually also equal to 0. Now this one, you can think about it in this way. This is limit x goes to infinity. This is 1 over x plus 1. And you remember your partial fractions. This is the limit as x goes to infinity of some a over x plus some b over x plus 1. A and b are constants, so it doesn't matter what your a is. This term over here is getting closer and closer to 0. This one over here is getting closer and closer to 0. So the sum of two terms that are getting closer and closer to 0 is just equal to 0. So that is why this limit is also equal to 0. Okay, so the short method of working out what a limit is when when your x is going to infinity is like this. So let's say we have limit as x goes to infinity of 5x squared plus 1 over 2x squared plus 2. Now if you look at this one, when x is going to infinity, in the numerator you have a parabola. It opens upwards. Okay, so your parabola in the numerator opens that way, it's going upwards. The same thing in the denominator, it opens upwards. So when your x values are increasing, you can see that the y values are going to infinity. They're getting bigger and bigger. So this numerator is going to infinity. So in the numerator, if x is getting bigger and bigger, y is getting bigger and bigger. Same thing in the denominator. When my x values are increasing this way, the y values are also increasing upwards. They're getting bigger and bigger. So what I end up with is a limit of this form. So it is of the form infinity over infinity. Now when you have something like this and you want to work out what its value is, it doesn't mean the value is 0 or it's 1 or it's infinity. It may be, but it doesn't automatically mean that is the answer because I'm getting infinity over infinity or it's of that form. What you do to work out this limit is you say the limit as x goes to infinity, and then what you will do is you look at your numerator and the denominator. You look for the highest degree of x, both in the numerator and the denominator. So in the numerator, the highest degree is x, is 2, and in the denominator it's also 2 because this is x squared, that is x squared, that they're both of degree 2. And what you would do is you would divide the numerator, or you'd factor out the highest degree of x that you have. Okay, so whether it came from the numerator or the denominator, it doesn't matter. That is what you would factor out. So here, what I have is 8x squared. I will factor this out. And then I have 5 plus 1 over x squared. And then in the denominator, I have x squared, 2 plus 2 over x squared. Okay, then these two can cancel. What I have left is limit as x goes to 0. In the numerator, I have 5 plus 1 over x squared. In the denominator, I have 2 plus 2 over x squared. So remember what is happening to x. X is getting bigger and bigger. So if x is getting bigger and bigger, 5 will not change because 5 is a constant. So 5 will remain the way it is. It doesn't have anything to do with x. But then this one over here, if x is getting bigger and bigger, then this value is going to go towards 0, because with each time that you make x bigger, then 1 over x squared becomes smaller and smaller, and it is eventually going towards 0. Now in the denominator, this 2, whether x is getting bigger or not, doesn't affect x, doesn't affect 2 rather, so it'll remain the way it is. And then this one over here, when x is getting bigger and bigger, this goes towards 0. Okay, so what is happening when x is getting bigger and bigger? My limit is actually equal to 5 plus 0 over 2 plus 0, and this is just equal to 5 over 2. So the limit of this function here, as x gets bigger and bigger, is not equal to 0. The limit is actually equal to 5 over 2. Okay. Let's look at another one. When we have limit as x goes to 1 of x squared minus 3x plus 2 over x minus 1. Now here, because x is approaching a specific number, what we do is we can try substituting into the numerator. If we substitute 1 into the numerator, we see that we get 0. And we do that in the denominator, we get 0 as well. So this is the form that it is in. So it is in the form 0 over 0. So what we can do to work out this limit, we see that we cannot substitute the way it is. What we should do is factorize instead. So I will factorize the numerator and see if there's anything that can cancel. So I have x minus 2, x minus 1 over x minus 1. Then this x minus 1 will cancel with that one, and then I'm left with the limit as x goes to 1 of x minus 2. And now I can substitute, and when I substitute, my limit is gone. Okay, so I don't have the limit all the way through. As long as I substitute, or when I substitute that over there, I no longer write limit as x approaches 1. I just write the limit value itself. So this is equal to minus 1. Okay, so the limit as x approaches 1, we can write this. So the limit as x approaches 1 of x squared minus 3x plus 2 over x minus 1 is actually equal to minus 1. Even though when you substitute 1 into the numerator, you get 0, and into the denominator, you get 1. You'll notice, even by using a table, that the value of the function, or the value of y, approaches negative 1. Another one, limit as x approaches 2 of x squared minus 4 over x squared minus 2x. So if you substitute 2 in there, you will see that this is of the form 0 over 0. So substituting directly or at the beginning doesn't work. We will have to simplify. We do that by factorizing. So here I have my limit. Because I have not substituted, the limit should still be there. Factorize the numerator using the difference of squares. And then in the denominator, x is a common factor. So I factorize that, then those two can cancel. So what I have is the limit as x goes to 2 of x plus 2 divided by x. And now when I substitute 2 into the value of y that I've simplified, I don't get any problems. So this is just equal to 2 plus 2 over 2, and this is equal to 2. Limit as x goes to infinity, x to the power of 4 plus x to the power of 3 plus 10 to the power of 23 divided by x to the power of 4 plus x squared plus 10 to the power of 50. Okay, then with this one here, we're going to infinity, or x is going to infinity, so our values of x are getting bigger and bigger. All right, so what we do here is we will factor out the highest power of x in the numerator and the denominator. So what I have is this limit as x goes to infinity, and I have x to the power of 4, 1 plus 1 over x plus 10 to the power of 23 over x to the power of 4. And then in the denominator, I have x to the power of 4, 1 plus 1 over x squared plus 10 to the power of 50 divided by x to the power of 4. Right, then these two, x to the power of 4, x to the power of 4, those two will cancel each other out. So I will be left with the limit as x goes to infinity of 1 plus 1 over x plus 10 to the power of 23 over x to the power of 4 over 1 plus 1 over x squared plus 10 to the power of 50 over x to the power of 4. Then we see what is happening. X is getting bigger and bigger. 1 doesn't depend on x. So whether x is getting bigger and bigger, 1 will just remain 1. This one over here goes towards 0 because you're dividing 1 by numbers that are getting bigger and bigger. So you're approaching 0. And then this one is also approaching 0 because the 10 to the power of 23 has no effect, because when you're dividing that, it's a constant amount. So you have a fixed amount and you divide it by a number that is just increasing. What you get is approaching 0. Okay, same thing over here. This will approach 0, and then that will approach 0 as well. Okay, so if we look at what we have left, the 1 over there obviously stays as 1 because it has no effect from x approaching x getting bigger. 1 is constant, it'll always remain 1. So what I have is 1. So here I should just say this is equal to, you can write this on the same line. This is just equal to 1 over 1, and this is equal to 1. Okay, all the other terms in the numerator go to 0. So when x is getting bigger and bigger, I will be left with 1 over 1, which is just equal to 1. The limit as theta goes to 0, sine squared theta over 1 minus cos squared theta. Okay, so here with this one, you can always try direct substitution first. If that doesn't work, then simplify and see what you get. Now if we substitute theta, which is 0, in the numerator, I will get 0. So I'll have 0. And if I substitute 0 there, I'll have 1 minus 1, which is 0. So this is of the form 0 over 0. So what I need to do here is use my knowledge from trigonometry and rewrite it and see if some things can cancel. Now we know in the denominator 1 minus cos squared theta, that is the definition of sine squared theta. So what I actually have is this limit as theta goes to 0 of sine squared theta over sine squared theta. So this is just limit as theta goes to 0 of 1, because sine squared theta divided by sine squared theta is equal to 1. And now what is the limit as theta approaches 0 of 1? This is just equal to 1, because 1 is a constant term. It doesn't matter what is happening to theta. Theta is approaching 0. 1 will always remain 1. So the limit of that is equal to 1. What about the limit as theta goes to pi over 4 of cos 2 theta over cos theta minus sine theta? So again, with this one, you will have to use your knowledge of trigonometry to try and rewrite this, see what can cancel. Because if I substitute pi over 4 into the numerator, I have 2 times pi over 4, that's pi over 2. Cos of pi over 2 is 0. I have 0 in the numerator. And then in the denominator, cos of pi over 4 is square root of 2 over 2. And then sine of pi over 4 is also square root of 2 over 2. And then when I subtract those, I get 0. So this is of the form 0 over 0. So I cannot substitute it. And what I do is I rewrite this. So this is limit theta goes to pi over 4. And cos 2 theta, you remember this is cos squared theta minus sine squared theta divided by cos theta minus sine theta. Then my numerator, I can factorize it using the difference of squares. So this is limit as theta goes to pi over 4 cos theta minus sine theta cos theta plus sine theta. Okay, you close your bracket and then divide by cos theta minus sine theta. Okay, these two brackets will cancel, and then I will be left with the limit as theta goes to pi over 4 of cos theta plus sine theta. Okay, now I will substitute, and once I've made the substitution, the limit, I will no longer write this part of the equation or of the expression. So then I will have cos pi over 4 plus sine pi over 4. This is square root of 2 over 2, or 1 over square root of 2 plus square root of 2 over 2, and this is just equal to the square root of 2. All right. And the limit if x goes to 3 of x cubed minus 27 over x squared minus 9. So again, try substituting 3 into the numerator. You see you get 0. In the denominator you get 0, so this is of the form 0 over 0. Then what I can do is I can factorize. So the numerator, I'll factorize it using the difference of cubes. So this is the limit x goes to 3, and then here I have x minus 3, x squared minus 3x, and it's plus, and then plus 9, then divided by x minus 3, x plus 3. Okay, now it is factorized, and see that these two will cancel. Then I am left with limit as x goes to 3 of x squared plus 3x plus 9. And now when I substitute, I don't have the problem of 0 over 0 or infinity over infinity. So this is just equal to 3 squared plus 3 times 3 plus 9 over 3 plus 3. So that's what I have. And then this, you can work it out on your calculator. And then I think you should get 9 over 2. Okay, so it's 9 plus 9 plus 9 divided by 6. Okay, so that is your limit. Let's do another one. So we have a limit if x goes to infinity of 2x over x plus 1. Okay, so our values of x are getting bigger and bigger. Now this time I have two straight lines, one in the numerator and in the denominator. So both of them have a positive gradient, so this is what they look like. So when x is getting bigger, going that way, you can see the values of y are just increasing. So this value over here is going towards infinity. And the same thing with the line in the denominator. It also has a positive gradient like that one. It also has a positive gradient like that one. So it is also going towards infinity when x is going towards infinity. So what I have is of the form infinity over I. Infinity over infinity. So when I have that form, what I should do is I should factor out the highest degree of x. So I have limit x goes to infinity. Okay, the numerator is already factored out. Then in the denominator, I'll take x out, and I have 1 plus 1 over x. Then this x and that one can cancel out. I will be left with the limit as x goes to infinity of 2 over 1 plus x. Then we said that when x is getting bigger and bigger, 2 will just remain 2 because it doesn't depend on x. It is a constant. Same thing with 1. 1 will just remain 1. But this one here, 1 over x, when you keep dividing 1 by numbers that are getting bigger and bigger, we see that this is approaching 0. Then what I have now is the limit as x goes to infinity. I just need to evaluate it, sorry. And this is just equal to 2 over 1 plus 0, and this is just equal to 2. So the limit of this function, 2x plus 2x over x plus 1, is just equal to 2. Let's try another one. let's say limit as x goes to infinity of x cubed plus 9 over 2 minus 5 to the power of 4. Okay, so we want to work out what that limit is. Now we look at the numerator. If x is getting bigger and bigger, you cube it and then add 9. The 9 almost has no effect because your x's are getting very big. So this will just go to infinity because it's just getting bigger and bigger. And then the denominator, what you see is the x to the power 4 is getting bigger, but it's negative. So this is actually going to negative infinity. Okay, but we still work it out in exactly the same way, in that we will factor out the highest power of the highest degree of x. So to do that, I will say limit as x goes to infinity. Now the highest degree of x in the whole fraction is x to the power of 4. So that is what I'm going to factor out. So x to the power of 4. And then here I have 1 over x plus 9 over x to the power of 4. And then in the denominator, I also take out x to the power of 4. And then I have 2 over x to the power of 4 minus 5. Okay, these two will cancel. I will be left with the limit as x goes to infinity. The numerator I have 1 over x plus 9 over x to the power of 4. In the denominator I have 2 over x to the power of 4 minus 5. Okay, and then what we do here, or what we observe, is if x is getting bigger and bigger, this 1 over x is actually going towards 0 because we're dividing 1 by a number that is getting bigger and bigger. And then the same thing over here, this is getting towards 0, this is going towards 0, and then this one will just remain as it is because x has no effect on it. Minus 5 is always just minus 5. So what I have, or what my limit is going to be, is just 0 plus 0 over 0 minus 5, and this is actually equal to 0. Okay, so the limit of this function is equal to 0. So you can think about it in that the denominator it has a higher degree. So in a way, it's like it reduces to 1 over x in a way, because the denominator is decreasing or increasing much faster than the numerator. Okay, you can think about it that way, but then we show it here that this is actually going towards 0. And you'll notice that this is true whenever you have a numerator whose degree is less than the denominator. So they will tend to go towards 0. Okay. I think the other questions are in the exercise. This is exercise 12.4. The first part says to use a table, so I don't think you'll have a problem with that one. Like you have limit theta goes to 0 of sine theta over theta. So we are asked to show this. So what you do is you need to draw a table. So you pick values that are getting closer and closer to 1. Okay, sorry, closer and closer to 0. Excuse me. Okay, and then you substitute them over there and then show that it is equal to 1. So you can see this is of the form 0 over 0. Okay, but we cannot really simplify this one for now. So what you can do, you must pick values. Start with negative, let's see, -1, -0.5, -0.1, and so on. You approach 0 from the left hand side, and then do the same thing, approach 0 from the right hand side. So you start with 1, 0.5, and then show that these values of y, these values of y are indeed approaching 1. So that's what the exercise means. It's just to demonstrate that you are able to substitute values into your equation. And then the same thing with this one. This is actually an interesting one, that the limit as n approaches infinity of 1 plus 1 over n to the power of n. This is actually equal to e. So the natural logarithm e, that is actually an interesting one. So try substitute values that are getting bigger. So you start with n, and then you look at your y. Start with 1. You see that you get 1 plus 1 over 1 to the power of 1. That is just 2. And then you go to 2, 1 plus half to the power of 2. You work that out, and you will see that these values, as your value of n gets bigger and bigger, is getting closer to e. So e is 2.72 something, I believe. Yeah, can work that out. And yeah, the others are pretty much the same way. Question 2 of exercise 12.4 is just the limit. So you'll see that the limit is either of the form 0 over 0, or it is infinity over infinity. So infinity over infinity, divide by the highest degree of x and see what goes towards 0, and those cancel out. And then 0 over 0, usually it's factorizing. Number 9 says long division or factorize. Number 9 is a quadratic equation. You should be able to factorize that one because it has x to the power of 4. I'll write it for those who don't have the book. So we want the limit as x goes to 2 of x to the power of 4 minus 7x squared plus 12 over x minus 2. You'll notice that this is actually quadratic because this is 2 squared, and that is 2 to the power of 1. So you can factorize that, and then I think you'll have difference of squares. Then your denominator should cancel. I think all the other ones left that I didn't do are pretty much the same. Number 4, so that's number 4 in the exercise, where you have limit as x goes to infinity, you have 5x plus x to the power of 3, x to the power of 2 plus 1 over 3x plus x squared minus 5. Here you must still do the same thing. That means you must factor out x squared because x squared is the highest power of x. So you are not going to factorize x out. You must factorize x squared out. Then you'll see that some of the terms tend to 0, and you should get a limit which is equal to 1. Okay, so do we have any questions? Are we okay? Right, if there are no questions, please try the rest of the exercises. It's very important that you practice